Hey there, I'm Tomomi, and here's Ayça.
Hi everyone!
Today we're going to talk about two concepts you hear a lot in modern AI, multimodal and multimodal. Let's start with multimodal. First, multimodality means that an AI model can reason across different input and output like reading text, looking at images, listening to audio, and combining all the information to respond intelligently. So when we say a multimodal model, it means a single AI model can handle multiple data types: text, images, audio, video, even code, all within one unified reasoning system. Now, multimodal is a different approach. Instead of one big model doing everything, you have a team of experts. Each model is specialized at something. One model handles vision, one model does translation, one generates code. Another might handle reasoning or classification or some other specialized tasks. Your app will orchestrate them together like a workflow. So which approach should you use? If your use case is simple, like reading an image and translating text, a multimodal model is usually enough. It's fast, easy to build, and it requires fewer moving parts. But if you need high accuracy, domain-specific components, or tight control over each step, multimodal systems make more sense. This can be more cost-effective too, since each large task is broken down into the smaller tasks. For example, you might combine a specialized OCR model for reading a restaurant menu, a translation model for foreign language, and an LLM on top for reasoning about the result, like analyzing ingredients and allergens in the menu. Now Ayça will show you an actual example.
Now you learned about what multimodal and multimodal means, and it's time to see them in action. I'm going to show you a quick demo where we'll use both of them together in a real app. Let's go. I've built AI Decision Engine Explorer for this demo, and I have a Japanese restaurant menu. I want to find out if there's anything gluten-free that I can eat. At the top of the app, I have multimodal explanation, which is multiple types of input like text, image, audio. And we also have multimodal, which is specialized AI models for specialized tasks. We are going to upload an image, and let me show you the menu we are going to use. This is a Japanese menu, and it's pretty complex for me. I don't understand much. And I'll just drag this and drop here. And I'll also type a text here. I'm allergic to gluten. Can you suggest what I can eat from this menu? Now we are going to analyze with AI, and we will see the decision in real time. First, we are calling Llama for Maverick for vision and OCR. We get all the text from the image. Next is translation using Cohere. We are doing the translation from Japanese to English. And finally, we are calling DeepSeek for the reasoning. Okay, here's the output we have. First of all, we have on top multimodal. We are using vision and text in this demo. And we have multimodal, and we use Llama, Cohere, and DeepSeek. Here are the outputs. We have all the Japanese menu items, and then they're all translated using Cohere. And finally, DeepSeek is making the decision. It has the user output. User has a gluten allergy, and then it lists all the items in the menu. So which ones have gluten and which ones are safe. And AI response finally comes from DeepSeek, and it suggests that some of the items here have gluten. And finally, our winner is the stir-fried vegetable set. Okay, so now I want to show you the code a little bit. We have Decision Engine TS, and here we are using all the models with their tasks. For example, Llama has OCR task, Cohere has translation task, and DeepSeek has answer question task. And how do we actually send the outputs to the user? Let me quickly check current input. Okay, this is the place we actually send inputs to our models. The first model gets original input, which is image for our case. The last model gets output of the previous one, and the user question. So to finalize this, we are getting the output summary plus user question and some directions with instructions. And the middle model gets the previous model's output. So output summary is going to be coming from the previous model. And when we are seeing this, we're using Decision Viewer TSX, and here every event message, every event.data, and event.thinking is actually showing us what's happening behind the scene of the models. And to do all that, we are using GitHub models, using the GitHub Access token. We're using Azure Inference SDK, and we are getting all of the models from GitHub Models for free for this. So this is how both of them work together in harmony, combining multiple input types and multiple specialized models to deliver one intelligent result. Thanks for watching, and we'll see you in the next one. Bye!